Is everyone okay that I do that? My reason is because I'm trying to get this to come to this measure. I want to show that I can get there, so I'm like, I mean, you're like, could I wait it later? Sure, but I want to put the negative down now. I get this negative what? Kt plus c, and what does that equal to? Now, who knows an easier way to write the left side? By a log property. That's natural log of this raised to the negative 1. Right? That's natural log of this raised to the negative 1, and I can just do. He knows it, good job. You can just flip it. I'm going to do that. Look, this is natural log of minus p to p. Ooh, it came out nice. I'm just going to keep that plus constant, everyone, because it could be plus or minus a c. Right? If you want to make it minus c, you can. You want to make that a minus c. Did everyone see what I did? Oh, there's a log property that says like 2 natural log of 5 is equal to natural log of 5 squared. So if you had a negative 1, let's say you had a natural log of x. I'm on as an example. I can move the negative 1 to the power. I get natural log of x to the negative 1, which is natural log of the reciprocal then, by log properties. So here, look what I did. I said that was this raised to the negative 1, and that to a negative 1 means it just takes the reciprocal. But hey, I'm sure not only you had it quite, I'm sure others wanted to see that too as well. So thank you for just asking about that. I didn't want to rush anybody on that. Just go, how the heck did he do that? Just by log property.
I heard Andrew whispering.
Yeah, he was like,
voices.
he was, I heard it too.
You're welcome.
Hey, you ready to eat it? What do you get? What's e to this? Ooh, you get, here we go. E to the negative kt. Dave, I can put the big c in front, right? Now, the only thing is, can you help me solve for a big P? Can you help me solve for a big P? So I get m minus 1 equals, no, m over p minus 1 equals c e to the negative kt. Almost done. Add a 1 to the side. M over p equals c e to the negative kt plus 1. Okay. Then what's p equal to? Good, I got enough room right here. I got enough room right here to write it. And if m over p equals this, I can multiply p on both sides and divide this. Look what p equals to. P equals m divided by this gigantic what? 1 plus c e to the negative kt. Ooh, we got it, we got it, we got it, we showed it. Now when this a value, I want to point out what's a in this problem. A is the c value when t equals 0. A is the value of c when t equals 0. So can you help me find out what we're going to put for that c? And when a is going to be the value of c when t equals 0. So did you figure out what we can put for that c? Because this equation had an a in it, right? So I just want to place that c somehow using that. A is the value of c when t equals 0. Well, let me go back to my work here. We'll keep looking. A is the value of c when t equals 0. Okay. Right there. How about right here? Now, what would a equal? A is the value of c when t equals 0. So would you plug a 0 in there? What would c equal? If t equals 0, help me, what would happen? If t equals 0, we get c equal to what?
1.
M minus p over p, that shows the second part. So again, a is the value of c when t equals 0. We have now presented what we have here. P is equal to I can replace this with a what? 1 plus a e to the negative kt, and then what's m equal to? When a equals m minus p naught all over p naught. We showed it. But these p naughts, you know what p naught means? The value of population when time equals what? 0. And thank you for bearing with me on that. I know it took a while just to do that. I just, you know, I don't want to just go, hey, here's the model, use it. Cool. Now I know what people are thinking. They're like, okay, we did the last one, but are you going to make me do that whole thing during a test? Here's what, everyone, for testing, I want to let you know, I will provide this for you. So if you're worried about that. I just think it's a little too much, a little bit too long during a test. You know, I think a lot of you can do it. Right? Now you have to be very careful with things. What, partial fractions? What else? Where's that funny U sub right there? And be careful of that. And then just getting that negative here. So hey, let's work a problem where we're given this. Well, but great job at that. It wasn't easy. Right? I mean, look at the textbook. This takes up 2 pages of the textbook to actually what? Derive this like we did. Pretty cool? All right. I can erase. So this is logistic growth. Oh wait, you still copying? I'm gonna wait. I did want to point out at the end how I just made this M right here. I turned that into an A because of this information. A is just it's the value of C when t equals 0. I think the next problem you're going to find pretty easy. Because all we do next is they give us some numbers and we use the formula. I don't know if you're going to like it. You're going to find it to be like a pre-calculus problem. We don't have to do calculus now, do we? If we're given this, the model. It's like a problem from a pre-calculus. Hold still. Good? Everyone good? Hey, great job. All right. All right, here's your problem. And let's suppose a population that grows according to the logistic model. Right here. I'll erase this. Suppose a population grows according to the logistic model. We're going to have to derive, now we got it right here. Here's the logistic model. P equals M over 1 plus A e to the negative kt, where A is equal to M minus P naught over P naught. What's P naught? So we get some of these letters down. Initial population. The P naught is the initial population. What's M? M is the carrying capacity, right? That's that carrying capacity of that population. If it's a town, you're like, it's not going to go over 20,000 people. All right? Fish in a lake or whatever it is. All right? Now, what else do they give us? They said the initial population is 1,000. Okay. The initial population, and I'm just going to put POP period, is 1,000. Hey, just so you get familiar with this, which number is going to be 1,000 in this crazy stuff? P. That P? Which one's going to be the 1,000? They said the initial population. The initial. The P naughts. Very good. Everyone see these P naughts? These P sub zeros, that's the initial population. Excellent. All right. Hey, they said the carrying capacity is 20,000. Where's that going? That's just going to be the M values. Everyone got that? So just remember that. M is that carrying capacity. But they didn't give you A, did they? You're going to have to figure out it. I don't think you're going to find it too hard. It won't require any calculus, because we already did the calc, right? Hey, we derived this. We showed how to get here. All right, anything else? They said the population grows to 2,500 after 1 year. All right. So they gave us this. They gave us this. They said the population grows 2,500 after 1 year. That sounds like they gave us that information or once we can figure out like that K value or something. We'll see. Well, what do they want you to do? What's the question? They give us all stuff. They want you to figure out what will be the population after 5 years. Okay. What will be the population? I'll just put POP period after 5 years. Question mark. I hope you don't find this problem too boring, because it is in calculus. It's something you probably see in a pre-calc class. You ready to just plug some numbers in? Step 1. Oh, let's do it like step by step, right? Step 1, find A. Step 2, find K. Step 3, we'll plug in 5 or T. Does that sound good? I'll repeat that. That's what we're doing. No integrals, right? It's already been worked for us. We know that this is what was derived as the model, the logistic model. Step 1, let's find A. Step 2, let's find constant K. And then step 3, just plug in 5 into our model. Sound good? All right. Step 1, find A. I don't think you'll find it hard. Let's see. But if you do, let me know if you have questions. What's A equal to? What's the M?
20,000.
20,000 minus
1,000.
all over.
1,000.
What is it? 19. Okay, step 1 stuff. That's it. Okay, getting. All right, let's find K. Step 2, find K. That's probably gonna take a little more work than that. All right, let's go find K. We found the A value. P equals M over 1 plus, put that number there, that's A, 19, e to the negative kt. So how do I get K? They give us some numbers that's going to help us get K. They said the population grows to 2,500 after 1 year. Where do I put the 2,500? That's the P, the population. What's the M value?
20,000.
20,000. I should have put it here, huh? I apologize. And we know M is 20,000, right? That's M. That's P naught. Um, 1 plus 19 e to the negative k times, how many years did it take?
1.
1 year. So negative k times a 1 means that little t turned into a 1. Now solve for k. And that's just pre-calc. I'll multiply this on both sides, divide that. Dave, you can do as many steps. You can do this in 3-4 steps. I think it's great. You know, you can manipulate quickly. I don't want to rush you. Want to see what I did? Multiply this on both sides, divide 500 on both sides. Oh, they said the population grows to 2,500 after 1 year. Now, if they said after 3 years, I would have had to put a negative k times 3. Very good. So does everyone see that? I made t go away. T is really a 1. You know, like here, a 1. Maybe I should write that so people look back and they go, "What was sitting? Where'd you take? How'd you take that t off?" Well, we really substitute a 1 there. Now what? What's that number? That's 8. 8 subtract 1 is? 7. Okay. So when I got the 8, then I subtracted the 1. Getting better. Isolate E. Isolate E. That t's not there. E to the negative k equals 7 over 19. L on both sides?
Yep.
Ln of. Ln of. So what is, well, I'll just call it negative k. What's negative k? 7 19. So k equals negative what? 7 19. Or if you wanted to, I mean, Armando, there was that trick where you could have said, oh, k is ln of 19 over 7. Similar to that one before. But I'm going to leave it like that. Do you know why I want to leave it like this? Because this formula has a what right there? So this is my suggestion. That's negative. I said leave it. So when you plug it back in here, for k, this turns into what?
Positive.
Positive. That's just my suggestion. If you were like, no, I want to do that cool reciprocal thing we did before with the property. So we've now found A, we found K. Last step, plug in K back in, and we're going to plug in how many years for T? Just be careful. Where am I plugging at 5? Not big P, that's time, right? That's time we're going to plug in a little t. There we go. P equals, I'm going to write it all out, 20,000 over 1 plus 19 e to the negative, makes it a positive, 7 over 19t. And I'm just going to plug in a what? A 5. Cool. Hey, I have another suggestion. What's e to the ln of blah? What's e to the ln of blah? Blah, okay. Do you see an e to the ln of blah there? So I'm just going to rewrite this. It's up to you. You got to put this in a calculator now. You're just plugging into what for t? But my suggestion is, you don't have to, but I think it looks a little better. If e to the ln of 7 to the 19 is 7 over 19, and I got 1 plus 19 times, look at this. That's the same thing. Not to confuse anybody. You make sure you see what I did so it's not bugging you. E to the ln of 7 over 19 means 7 over 19 also raised to the t. That's just 7 over 19. But I'm thinking as it's still the power. I just find that easier to type into my TI-84. But you might be like, no, I'm just going to do that. Okay. Be careful though, right? Be careful. You're going to put parentheses here, you're going to put parentheses here. What's going there? 5. So and what is P of 5? I mean, just plug in T. P of 5 means you get 20,000. 1 plus 19,000. 7 over 19, all raised to the 5th. But put a big parentheses around that. And I don't know, I made this up, so you're going to have to tell me what you get. I'm going to make sure 2 people get it. I know the population is going to be under the carrying capacity, right? But is it 15,000? I don't know. What do y'all get? Did it hit 16,000?
17,000.
Did it hit 17,000? All right, let's go to the closest integer. 17,000. 750?
15.
Oh, 15. Right. There you go. It was approaching the what? Let me do the graphs again. What was approaching? Yeah, what was the initial population? 1,000, and then it kept, a rapid increase, but after 5, what? This was after 5 years, it was getting closer to that carrying capacity. But at 5 years, where was it? At 5 years, it was at 1775. Cool? Excellent.
So, I just have a question about, right, yeah.
That thing?
So, no, the T of that.
Okay.
So the T didn't become,
Good question. They used to confuse me as a student. What's happening here is we're saying like, you know, like you had like, if someone said 2 to the 5th times 2, you and I can look at that math problem as 2 to the 5th raised to another 2. We can look at it like that. So in this case, I'm looking at it as e to the ln of 7/19 raised to a t. That's how I'm looking at it. And I'm like, oh, so that's just 7/19 to the 2. If that helps, I'm going to do this. And you make, it's like all that raised to that power. How cool. And another thing, Nicholas, if it bugged you during a test, just be like, okay, I'm just going to type it like this carefully. I'm going to type it like that carefully.
It's 19,000 there.
Oh, that 19?
19.
Oh, right there, it's 19. You're the best. He says typo on the board. This is just a what? 19. That didn't affect your answer, did it?
No.
Oh, good. He goes, no, I didn't type what I wrote on the board. Thank you. Thank you for typing it correctly. And thank you for noting that error. He said that's just a 19 there. Awesome.
So you said k equals negative ln, or 7 over 19, but how can you get the negative up there?
Great question, because the formula had a negative already in front of it.
Okay.
And that's why I left it negative. I know, something else, just be careful on the test, right? Is that any good with that? Yeah, super job. The only thing weird about this, again, no calculus here, and I just, because of really time constraints when it comes to this, I don't make you derive that, like we just did. Did you see that? During a test. It's good, it's just, that's a monster. You see the monster we just did? To derive that. That's the algebra derive. Hey, the last thing we do, this won't take long. Look what I have here. This will seem pretty light for what we're doing. Curves defined by parametric equations. Have you ever heard of that before? We'll do a couple. What's a curve defined by a parametric equation? This is 10.1. So curve defined by parametric equations. Maybe, if all I taught was calculus 2, I don't know if I see such a need for this section. I would look at this section perhaps a little with a grin, like, how we're coming. But teaching some of the higher level courses, such as calculus 3, you see why there's such a need for parametric equations like that. Parametric equation means you just have another parameter that you can use when you talk about the relationship between x and y. So I just want to give you an example. Here's a set of parametric equations. X equals 3 sine of t, and y equals cosine t. And what we're going to do is we're going to sketch the curve. Now what do they put between these x's and y's? They usually just put a comma between them. And this comes from 10.1. Which problem is this like, if anybody's curious, from section 10.1? From section 10.1, I wanted to start with this problem. I thought it was pretty. This is like number 12. It's also like number 8. But this problem is definitely like number 12. And they say, sketch the curve by using the parametric equations. All right, so we got to sketch the curve. So I'm just curious, has anybody ever seen this before? You know, how have I always written curves up till now? Hey, y equals x squared. Did you have a t in there? That t is called the parameter. It could have been another variable. It could have been m. Okay? It could have been lowercase m, but they always use t. It's a common parameter, but you could use m. That's a parameter. And they call these parametric equations. But boy, is it useful when you're doing things in three-dimensional space like in calculus 3. So we got to get used to this. So how do I sketch this curve? Everyone, we just use the old school method. You make a table. How about that? So remember that. You go, even in calculus 3, how do I sketch parametric? How am I going to sketch this curve? Old school, you just make a table. And you make up these t values, and you what? You plug them in, you get points, and what do you do with your curve? You connect them, right? And then you go, can I use a calculator? Does it have parametric mode? It surely does. You can explore with the calculators too. But I'm going to start out like I don't have a calculator or anything. So I need some help. Who's got some suggestions for t? I don't think t could be the best. By the way, can t be negative? Yes. Keep that in mind. Parameters can be negative. I don't think this is going to work so well. So any suggestions? Yeah, I like it. You hear suggestions? He's using those numbers where sines and cosines are needed. Pi, what else? 3 pi over 2. Let's go up to 2 pi. Maybe we'll get a pretty decent graph going here. He'll leave enough space right there. Great suggestion. So how do I get this curve going? Sketch a table. Remember, you can use your technology for support. You know that mode button? There's something called parametric, and you can look at the graph actually there too. Cool, people are looking at it right now, that's fine. Hey, what's 3 times sine of 0? 0. What's cosine of 0? All right, what's 3 times sine of power 2? 3, what's cosine of power 2? I'm not rushing, am I? Okay. What's the 3 times sine of pi? What's cosine of pi? Oh, looks like a pattern to this. What's 3 times the sine of 3 power 2? Negative. Cosine of 3 power 2? And finally, shouldn't this be the same as this? And what do you get? Now everyone notice, as t increases, I'll just draw an arrow, how did this curve lay out? Let's see. Look, this is x, this is y, like we've always drawn the xy coordinate plane. We just use this parameter to make this sketch. Alright, 0, 1, 0, negative 1, 1, 2, 3, 1, 2, 3. It started here, then it moved up to the what? 0, 1 is, I don't want to plot this incorrectly, I almost did. Wait, which way is this thing stretched? Where's that point? Is that here or here? I don't want you to mix it up on the test. 0, 1 is, right down here. Where's this point? Here. Where's this point? Right there. Where's this point? Right there. And when I draw this curve, it's not a circle, but it's like an elongated circle. Do you know what they call that?
Elliptical?
An ellipse. This is an ellipse.
Are they directional in this case? You have to draw arrows to show which way they want to go.
Absolutely. And when, even in the problem, they'll state that. So let me read the textbook. And I just need you to draw a tiny arrow on this path. They write this. Indicate with an arrow the direction in which the curve is traced as t increases. So somewhere on the path, can you just put a slight arrow? Was it going that way or this way? Think of it as a bug moving. Think of this as, this represents the path of a bug. Which way was it going? There you go. You can put it anywhere you want. So very good question. They do put that in the direction. So on a test, I'll write that too. I'll say, indicate with an arrow the direction of its increasing. Cool. Hey, I used a table. Did anybody take a chance and look at this on a calculator? Did it look cool? How was it? Thumbs up or down? They're like, yeah, like this. Now, I want to show you something. Could I have worked this problem by eliminating the parameter? What do y'all think? Could I have worked this problem by eliminating the parameter? I think so. What's that cool identity with sine squared and cosine squared? Sine squared plus cosine squared equals 1. So when you gotta be a little creative, but I'm gonna do it. I'm gonna be able to eliminate the parameter to come up what's the x and y relationship, because I remember taking conics in pre-calculus that made these elliptographs, these elliptic curves, okay? So what I'm thinking is sine squared plus cosine squared equals 1. What's bumming me out, it has a what there? A 3. But do you all agree this is the relationship? If I just do x squared over, what's 3 squared? If I take this and divide a 9, and then I add this, do you all agree if I substitute this back in here, it turns into a 1? Because sine squared plus cosine squared equals 1. Now I'm being creative. I'm being creative. That means you wouldn't have to do this on the test, but you all see what I'm doing? Isn't this true? And you recognize that from pre-calculus? This is a what? That is that ellipse. That's that ellipse. I just wanted you to see that some of you in this class might go, oh, I'm going to eliminate the parameter and get it all in y's and x's. Cool? So, hey, when the book directions say eliminate the parameter, that's up to you if you want to do that. So, on this next problem, this is the last problem. This is number, I wanted to take and this is an even problem. This is number 8. Can I erase this? They go quick, don't they? That's what this section is, just sketching parametric curves.
So that's x squared over 8 plus y squared.
If you wanted to, that would be the exact, if you graphed this like it was in a pre-calc class, you'd get that same curve. Look, try it. What's the,
That would basically be y squared over 1 squared.
let's see, if you plug in, if x is 0, what would y equal? Plus or minus 1, and then what if y equals 0? What does x equal to? See, you get those same points. Isn't that cool? But I didn't want you to think you had to do that. It's just sometimes the book will write, eliminate the parameter is an option. Okay, last one. And this is number 8. I just want to see how you do it. I want to do this because the problem's not in the back of the book. They get x equals t minus 1, and y equals t cubed plus 1, And then they gave specific directions, only sketch the curve from -2 to 2. Okay, well, let's just sketch the curve. If I went from -2 to 2, make a what? Now I don't have to worry about the pies and everything, right? That's the old school method. I know you will know how to do that, and I know you could sketch this curve. Do you agree it's going to be pretty easy? Just plug in the points? I was wondering if someone could eliminate the perimeter. You might find it easy. You can eliminate the perimeter. What would y equal to? What would t equals over there? T equals x plus 1. I could substitute it there. You agree? Let me do it again so no one's freaking out. I'm gonna look at this because I'm gonna recognize this from my pre-calculus days.
So you're substituting that equation into the other?
That's right. I have to solve for t though. T would equal, what would it equal? X plus 1, and I'm gonna take this and I'll put it in there because look, I recognize this. You all recognize this? That's the snake. Which way did it shift? Up 1 and left 1. Ow, I know this guy. He went like this. And then I went like this one. I'm like that. But if you do this, of course this works too. And when you help me plug this in, what do you get? What's that? -3. I get you all to back me up so I don't mess up the arithmetic here. What's -2 cubed?
-8,
What's -8 plus 1?
-7.
Okay, so it's a -3, -7. A kaboom. What's -1 minus 1? Ooh, that's 0, huh? Is it? Yeah.
Yes.
So that's here. What's 0? Okay with that, Andrew? I plug in -1 there, -1 cubed is -1 plus 1 is 0. And then 0 I get -1 and 1, how about a 1? 0 and 2, and what's going on 2? 1 and, whoops.
Nice.
And when I got to cube that too, that's 9. So did this model this? Yep, went through here, went through here, went through here, -1, 1. 0, 2. 1, 3, 4, 5, 6, 7, 8, 9. No, we just, no. Now, which way was it increasing? Well, I gotta show the path as t increases. Was it going that way or that way? It was going that way as t increased, right? So I'll put an arrow on there. Who exported with a calculator? How did it do? They might try this with their calculators. Does it do a pretty decent job with parametric? Okay. Feel free to explore it. Just go to mode if you want to play around. Just go to mode and play around. You gotta play with that window maybe. Cool. Hey, great job everyone. Super job of that.